Welcome to Brain Vision.
In this problem, we have a mower which hovers very close to the ground, and this is done by drawing in at a given speed through a given intake. The air is then discharged at the ground through a different cross-sectional area. We want to calculate the air pressure which the lawnmower exerts on the ground, and this is when the weight of the mower is freely supported. So the first thing we need to do is calculate the mass flow rate dm dt. So just looking at our diagram, we can see that on the ground we have the weight of the mower acting downwards, which is its mass 15 times 9.81, that's the value for g. And acting upward is the air pressure, which has a force which is the pressure times the cross-sectional area, 0.35 square meters. So firstly, we'll calculate our mass flow rate dm dt. This is the density of air times the cross-sectional area of the intake A times the speed of the air into the intake VA. So the density of air is 1.22 kg per cubic meter. The area of the intake is 0.25 meters squared, and the air is moving at a speed of 6 meters per second into the intake. And so the mass flow rate is 1.83 kg per second. Now that we have the mass flow rate, we can apply the steady flow equation and take the upward direction to be positive. So the steady flow equation tells us that the sum of all the forces in the y direction is equal to the mass flow rate dm dt into the y component of Vb, which is at the exit, minus the y component of Va at the intake. So in the y direction, we have the pressure acting upwards. So this force is the area over which the pressure acts times that pressure, 0.35 times P, minus the weight of the mower acting downwards, which is 15 times 9.81, and this is equal to dm dt, which is 1.83 into 0, since at the exit air is moving horizontally as it hits the ground and there are no y components, minus the speed of the air at the intake is 6 meters per second, but that's downward, so that's negative. And so if we rearrange this equation, we can solve for the pressure, the air pressure which the lawnmower exerts on the ground, P, and we get the pressure P to be 452 pascals.